All right, let's do hard mode. Okay, so we're going to talk about composition versus inheritance. All right, and again, this is an object-oriented programming concept. Has nothing really to specifically to do with TypeScript. Okay, like you do this in Java, you do this in C Sharp. Okay, it is a transcendent concept, so don't think it has to do with the language. The language only just tells the syntax of how it's done, but the idea will remain the same. Okay, so let's say I have an app that deals with birds, right? So I've got a parent class called bird, and I went really fancy. I said, you know what? I don't want you to instantiate the bird class. Okay, I only want you to inherit from it. I don't want you to instantiate. So I'm going to make it abstract. All right, and birds have a speed, okay, and birds have a method called fly. So birds fly makes sense. Okay, so if the default method will say flying high in the air. I've got two classes, hawk and eagle. Okay, hawk extends bird, it inherits from bird, and it flies, and hawk has an override because hawks fly and catch mice. And then eagles are also birds, and they fly, but they fly around Murica. Okay, that's what the eagles do. All right, so everything's cool, right? I've got a bird class, it's abstract, you cannot instantiate bird. I know that if you do inherit from bird, you fly. If you inherit from bird, you fly. Remember, when you inherit from something, it copies over all the properties and all the methods, meaning that if you inherit it, you fly. Like, you get this. If you don't want this fly method, then don't inherit from bird. But if you inherit from bird, you sign up for having a fly method. So my app is working hunky-dory, right? I got hawks, and they fly, and eagles fly, and I can even make hawks fly in a special way, and my eagles fly in a special way with overrides. I can take the same method and replace it with my own implementation. Everything's going great, except one day my boss comes in and says we need to add penguins, okay, to our app. Okay, cool, penguins are birds, so it makes logical sense I would take penguins and have them inherit from birds. Okay, cool. Wait a second. The bird class has a fly method. Alright, well, I want penguins to be treated like birds. This is a bird app. But penguin, if it inherits from bird, is going to get a fly method. Okay, well, I guess I can override it. Alright, I'll override it, make my own fly method, and I'll just say penguins don't fly. Think about this for a moment. Does that make sense? It really is kind of awkward, right? Basically, I'm inheriting from a class, and I'm getting all its properties and methods. And that's the point of inheriting from a class. The point of inheriting from a class is I get all the properties and methods, so I don't have to recopy them. And I also get to use polymorphism because penguin gets to inherit from birds, so I can treat penguin and eagles and hawks in kind of the same way because they're all birds. So I get that too. But the problem is I have this method I'm overriding, and I'm overriding it to say that the method shouldn't exist. And that doesn't make any sense because now I'm questioning whether I should inherit from bird, but I want to inherit from bird because penguins need to be treated like birds along with eagles and hawks. So on the one hand, I want penguins to be birds and be treated like birds. But on the other hand, penguins don't fly, and I'm stuck with this fly method from the parent class. I'm stuck with it. If I get rid of this method in the parent class, I guess that could make sense. So for example, if I could get rid of it here, but then I'm going to have to remember that every time I make a new bird, I have to remember to put the fly method in it. That kind of undoes the point, right? I liked having a fly method. So let's say tomorrow I went class, I don't know, dove extends bird. I have doves now, and I don't have to write let's say the dove, I like the regular fly method from the bird class. Okay, I don't want to put an override here. And now, if I get rid of the method in the parent class like this, I have to remember to put it in all the children classes. So now I have to go back and remember every time everything that's going to be a bird. So it kind of undoes the convenience of having a base method in the bird class. So okay, I'm kind of stuck now because now I'm basically saying penguins don't fly. Here's a fly method which really shouldn't be there, but I'm stuck with it. So this is a case of when inheritance is kind of awkward. All right. So here's what I meant by I wanted to treat penguins like other birds. So like for example, let's say I have an array of birds. I can take a hawk, an eagle, and a penguin and put them all in the same array, right? And that's nice. I want to be able to do that because my app is like bird watching or something, and so it's got birds. So they should all be treated the same. But I'm stuck with this stupid fly method, which logically shouldn't even exist in the penguin class because penguins don't fly. Why do I have a fly method for something that doesn't fly? All right, so this is a common problem with inheritance. Inheritance is great for not repeating yourself. So there is a principle called DRY. DRY. It stands for don't repeat yourself. Okay? In code, we don't like to repeat ourselves. If I can write one piece of code and then have that spread, propagate and spread out throughout the rest of my app, that's beautiful because this way, like if everything inherits from bird, then I can just use the base implementation. If I change this fly method in bird, everything that inherits from it that doesn't override it will just use my base implementation. That's really efficient. Also, it makes certain I have like lots of control over this method. Except now we have this really awkward thing where it's like I have penguins, but really penguins really shouldn't have a fly method. So how do I solve this problem? We're going to use a different technique called composition. We're not going to inherit from bird any longer. Let me give you an example. We're going to have an interface called iFly. Now, I haven't done this before, but like now with interfaces, I like you to start putting I in front of them because that's just a common naming convention. So it's very common to do like I fly, I player, I customer. Okay, if it's an interface, you put an I in front of it and then whatever else there is there. And yes, if the word begins with I, you'll have two I's next to each other. All right, now I made this fly interface. This interface is for anything that uses this interface as a thing that flies. If you implement this interface, you must have a method called fly and that doesn't return anything. I'm going to repeat that. Remember that interfaces, they don't tell you what the method does, they just tell you that the method should exist, along with properties. Interfaces are about whether or not something exists. So now I've got my Falcon class. Falcon will inherit from bird but implement the interface. So now I can treat things that are completely different from one another, but they share in the fact that they fly. So for example, notice I have helicopter, implements iFly. Falcon implements iFly. This is composition. What I'm basically saying is a falcon is a thing that flies, a helicopter is a thing that flies. Because what if my app has to deal with like a new class? Remember, this is all about like what happens when things change. One of the things that I hint at in class, and you're going to learn over time, is that apps are changing things. Google Maps is constantly being added to and bugs are being fixed. There really isn't, I mean, sometimes there's a point where the software is quote unquote done, but if you think about how many times they've upgraded Microsoft Excel and Word and all of these other like mainstream, highly used programs, software is actually really in a state of flux. So we try to think to ourselves, what happens when things change? This is very flexible because falcons are things that fly and helicopters are things that fly. I would never ever have helicopter inherit the bird class. That makes absolutely no sense. But if you think about it, if flying were only in the bird class, then I would have to. So let's picture I took flying out of the bird class and put it in this interface. Now I can treat anything that flies, anything that uses this iFly interface is the same. So I can put the helicopter and the falcon in the same array. And I don't have to worry about whether or not about methods. I can take that out and put into an interface. So like just pretend that okay, with bird, I took this out. Okay, I took this out and put it into an interface. And so now, once it implements the interface, falcon is still a bird, so the falcon can be treated like other birds, but it has this interface fly, so I know for a fact that falcons can fly, just like helicopters can fly or hot air balloons. So like the next time my app changes and they say, okay, Jonathan, we have like I don't know, like F-16s, fighter jets, so like class fighter jet implements iFly. Okay, and I can have that, or I can have class hot air balloon implements iFly, right? Because flying in my app has a certain meaning, but could be many different things that could fly that I don't want to have inherit from one another. I don't want to have helicopter inherit from bird. That makes absolutely no sense. So falcon and helicopter really shouldn't be in the same tree, but I can still link them together through the interface. Okay, well, the interface allows me to compose things. I can kind of build my own class. And this is what composition does. Okay, we're able to compose or like piece together, okay, our objects based on our needs. So now falcon can be treated like a bird, and it can also be treated as a thing that flies. So this is much more flexible code, and it makes a lot more sense. So when I do penguin, penguin can be something that extends bird but does not implement iFly. So that way, there's no like code in penguin that says penguins don't fly. I just don't have a fly method for them, for penguin. And that makes logical sense. I shouldn't have a fly method for penguin because penguins don't fly. This is hard mode. Okay, this is difficult. Composition takes a while to get. I didn't get it the first time it was explained to me. All right, but it's nice. It's about not having to deal with like you don't want code. Like for example, like I didn't want to have code that said I shouldn't be using this code. This is like dead code. Okay, you don't want code that either that sits there and does nothing, or sits there and basically just sits there to be confusing, like or shouldn't exist. Like you want your code nice and tight. You want only the code to exist in your code base that is necessary to get your app done. You really, if you have no excess code, like because the more excess code you have, the more chance you have for bugs. Okay, the more like you want to trim the fat. So logically, you only want classes and objects to have the functionality that they need and nothing more. So because of that, penguins don't need this functionality. So if I'm doing it correctly, I would like it so that penguins don't have to have this functionality. If I use inheritance, I'm kind of forced to. If I use composition and have an interface called like iFly, I can pick and choose. People tend to favor composition over inheritance. Okay, typically when they're designing software. And composition is just by definition more flexible. Okay, inheritance basically says like once you inherit from the other class, they're stuck together. Like that's it. Like whatever is in the parent class trickles down to the child classes, and in the when you first set it up, that may be okay, but in the future, that may make things awkward. Okay, again, this is not about your first draft of your program. It's about next week's version of the program, next year's version of the program. What happens when we add new things? And how easy is it for us to add new things and have it make sense? It will take some time before you understand what I'm talking about. I know you're probably listening to this video and like, what the hell is Jonathan even saying? Okay, but see if you can really appreciate what I'm talking about. See if you can really appreciate that this fly method should not be in Penguin, but if I use inheritance, I'm forcing myself to. If you can get that part down about why that would probably be bad, you can understand why we use composition.